Okay, another question. Let's say we have an inflationary problem. Here we have our equilibrium is now above full employment. So we have too much spending. This is too much income there, trying to buy too much. And therefore we want to bring income down, equilibrium income down. We want to get it down to 7,200. Well, the difference with that, if you take 10,000 minus 7,200, will be $2,800 billion. So that's our policy goal. We want to bring down equilibrium income by $2,800 billion, and that will get us to where equilibrium is equal to 7,200. So using the spending equation, we have a spending fiscal policy equation or a tax fiscal policy equation. So we can use a spending multiplier over here, use a tax multiplier over here. Spending multiplier, in this case the MPC is 0.8, and so it's 1 over 1 minus 0.8, which is 1 over 0.2, and 20 cents goes in $1.05. Tax multiplier will be 1 minus spending multiplier, and that would be 1 minus 5, which is 4. You can also take the negative MPC over the MPS. That's a negative 4. Try to maintain the focus there. And so if you take the MPC, which is 0.8, over the MPS, which is 0.2, 0.8 divided by 0.2 negative would also give us a negative 4. We want to bring down income by $2,800 billion. The spending multiplier is 5. We want to know what would be the change, times. What would be the change in G here to do it? Over here, we want the same $2,800 billion. We're going to use a spending multiplier over on the left side. We're going to use a tax multiplier on the right side. It would be negative 3 times our change in taxes. So two calculations. Oops, negative 3, that was the one we just did. Negative 4. So we get our calculator. We want to divide both sides by 5, and so we're going to take 2,800 divided by 5, and that is 560. So the correct answer here is we want to decrease government spending by $560 billion. We want this to be a negative number because we want that to be a negative number. Here we're going to divide 2,800 by 4. Tax multiplier a little bit weaker, and that's 700. So we want to increase taxes by $700 billion. That would be a restrictive fiscal policy to counteract inflationary pressures. We could use a combination of both. That becomes a bit more complex. I won't do that on the test. I'll either have a question about using the spending multiplier to solve the problem or the tax multiplier to solve the problem. Now there is one time I might use them both at the same time, and I would phrase it this way. What would be the effect if both government and taxes both move in the same direction by the same dollar amount? So for example, what would happen if they both would increase by $600 billion? Now, students might think, or the average person might think they're going to cancel out, but they're not. Let's go ahead and do it. So it's going to use our multiplier. The MPC is 0.75, and so the spending multiplier is 1 over 1 minus 0.75. That's 1 over 0.25, and a quarter goes in $1 4 times. We did that when we had the table earlier. And then the tax multiplier is 1 minus 4 minus 3. And that's from the MPC being 0.75. So now if G goes up by $600 billion, it gets multiplied by 4. If taxes go up by $600 billion, it gets multiplied by a negative 3. So $600 billion times 4 is 2,400. So that by itself would drive up income, and this would be equilibrium income, would go up by $2,400 billion. But if I take my taxes, my $600 billion increase in taxes, and multiply it by -3, it would be a negative 1,800, and that would drive income down. The net effect, higher government spending of $600 billion is driving up income by 2,400. The higher taxes is going to reverse that by negative 1,600. The difference is $600 billion, which is equal to the number they were both increasing by. So this is the concept known as the balanced budget multiplier. And a balanced budget multiplier means if you change government spending and taxes by the same dollar amount in the same direction, what will happen to income? And the answer is it's going to multiply by exactly 1. So we would have our change equilibrium income equal to the balanced budget multiplier, which is 1. And it'd be times by the dollar amount change in both G and T. So whatever, it's both, it's a change in T, change in G, not multiplied together, just whatever dollar amount that is. It's going to change this by 1, exactly what that is. So on the test, if taxes go down by, say, $100 billion, government spending goes down by the exact same amount, that meets the definition of a balanced budget multiplier. Balanced budget means there's no effect on the deficit or surplus. It cancels out in terms of the budget. So it is correct, this does cancel out in terms of the budget, but it doesn't cancel out in terms of what it does to the macroeconomy. Well, if this is $1,000 billion in negative, we put 1,000 right there. You times that by 1. I don't have to separate it up here like I did here. I know it's going to be 1. We proved it up here. We actually not prove it, but we gave one example. And this means our income is going to go down by 1 times that, also the same $1,000 billion. So it does cancel out in the budget, but it doesn't cancel out in terms of the effect on the economy. That's because the tax effect is again going to be a little bit weaker. So balanced budget multiplier is equal to 1, always the case, equal to 1, meaning that the multiplier effect of a change in taxes offsets all but the initial production triggered by the change in government's purchases. So the taxes has just a little bit weaker effect and negates almost all of it except for that initial amount. So it negates all the multiplier effects of the government purchase or decrease or increase, but not that initial impact. And that's the end of lecture 1.